I don't have any confidence in my ability to do the algebra correctly because I'm not going to take the time to do it really correct. But I'll tell you what I would do. I know I could get it right. You'll see what happens. All right, so we always start the same way with a drawing. Our drawings should be simple. We have a squirrel, and the squirrel jumps straight up from a branch. And what we're expected to think here is that she jumps straight up in the air, and then she goes straight back down. And how does she miss the branch? I don't know. Maybe the branch breaks and she comes back down where the branch was. Or maybe there is some horizontal component to her motion, but we're just ignoring it. Either way, we don't know nor do we care about any left, right, forward, back motion. It's only up and down. She jumps up. We don't know how fast. She is, the branch is 4.6 meters above the ground, and she's in the air for 1.2 seconds. And that's the only thing we're told in this problem. We know what her motion is going to look like. She's going to go up, slow down, come back down, and hit the ground. But we don't know how fast she jumps. We don't know how fast she's going when she comes back down. We don't know how far up in the air she goes. We don't know any of that stuff. So what do? We follow the system. And the system says, tell me where location 0 is. This is one-dimensional, so we just need 1, 0. So I'm going to say the ground is position 0. I'm going to say that up is positive. That means that my free fall acceleration is negative 10 meters per second squared. Negative because down is negative in this particular reference frame. That's all we know. So let's start putting things together and see where we get. Our initial position, we know that. She's 4.6 meters in the positive direction away from position 0. So she starts at position 4.6 meters. Her final position is the ground. So that's position 0. Her initial velocity is unknown. Her final velocity is unknown. Her acceleration is negative 10 meters per second squared. And the amount of time she's in the air is 1.2 seconds. And that doesn't seem like enough, does it? Because when I look at this, I'm like, how do we solve a problem if we don't know the initial or the final velocity? Could we break it into pieces? We could. We could break it into pieces, and actually it would make it more difficult to solve if we did that. The correct way to approach this is we're going to go down the list and we're going to figure out which of our equations has the information that we have along with one unknown, which is what we're looking for. We want to know her initial velocity when she jumped up. This is the value we're looking to find. So we need an equation that doesn't have final velocity, because that would mean we have two unknowns. So this equation has final velocity, so that's off the list. This equation has final velocity, then that's off the list. The only equation left is this one. That doesn't seem like it should work, but it does. We have final position, we have initial position. We don't have initial velocity, that's what we're trying to find. We have time, and we have acceleration. We have 4 out of the 5 variables that we need. What we're trying to find is the initial velocity. So on a quiz, what I would say is, I'm going to put this, and this, and this, and this into the solver, and I'm going to use this equation to solve it. And that would be full credit, right there. If you do this, you get full credit. If you wanted to solve the algebra, by far the easiest way is solve for the variable first, which sometimes, if you're solving for time, sometimes that means you set it up as a quadratic equation equal to 0, and then you plug everything into the quadratic formula. But for this, we're not looking for time. So all I need to do is some subtraction and a little bit of division. I'm going to subtract y0 from both sides. So that's going to be y minus y0. I'm going to subtract 1/2 ayt squared minus 1/2 ay dt squared, and I'm going to divide by time. That should equal my initial velocity. And when I put the numbers in, I get 0, which is my final position, minus 4.6, minus 1/2 times 10 times 1.2 squared, all divided by 1.2. And I can't do that math in my head. Maybe 20 years ago I would have been able to, but I can't now. So I'm going to take this calculator that doesn't have batteries. Then I'm going to take this calculator that does have batteries, and it's going to be 4.6 negative minus 1/2 times 10 is 5, minus 5 times 1.2 times 1.2. See how I'm doing this too fast? Foolish. Don't do it the way that I'm doing it. Write out the answers. Divided by, oh, this is negative 10. See, there's my, I already made a mistake. Negative 10. So that is 4.6 negative plus 5 times 1.2 times 1.2. And that is 2.6 divided by 1.2. If I did that math right, it should be about 2.17 or 2.2 meters per second. But that could be very wrong because I did the algebra too quickly. Yeah.
Why do you swap the signs negative?
Oh, because it was negative. I didn't swap it. I wrote it down incorrectly.
I mean, like, from the equation above.
Here?
Yeah.
How did I make? Because that's the algebra. I can explain it. Well, actually, I probably won't explain it to you. That's just, I did the algebra. I did it quickly. Yeah.
Would that be like way easier just to swap the velocity, the start velocity, the other side, and then do it that way?
You can solve it algebraically however you want. This is how I do it.
Okay.
Yeah, and I'm not, this isn't me doing this just like to prove a point. This is how I solve these problems. Actually, this isn't how I solve these problems. If I were doing this, I would actually write everything out. This part right here, I would have written negative 4.6 minus, and then I would have done this math first and written it separately. All over one point. Like, I show all that stuff, not because I've been taught to and because I'm afraid I'm going to get in trouble, but because I know I'm more likely to get things right if I do the work in the smaller my steps are, the less likely I am to make a mistake. All right. Any other questions? So just remember this right here, the drawing, the variables, identifying which variables go into the solver, which variable you're looking for, and the equation, that's full credit. If you choose to do the algebra, it's fine. If you get the wrong answer, it's not going to hurt you. Okay? If there's more than one problem, which there will be, then my advice to you is get to this point on all those problems first, then go back through and try to do the algebra. Don't waste time doing the algebra unless you know you can get it all done, unless you are like so solidly confident in your algebra skills that it's just trivial, which very well may be the case for some. Okay, other questions? All right, let's see what you can do with predicting projectile distance. And remember, those